So, spoilers, the thing that we're finding is actually a definite integral. The area underneath a curve is another thing that the definite integral tells us. So, derivatives is telling us slope. The antiderivatives actually tells us the area underneath a curve, which is pretty cool. So, we can find upper and lower estimates for this thing by just making that little adjustment of which ones we're going for. So, if it's a decreasing function, so if f of x decreases, eh, so f of x looks like this, then the one that is going to give us that bigger approximation, if that thing is decreasing, is going to be whichever one grabs these pieces. So this will give us the upper estimate. Because you can see as I draw those blue rectangles, most of those blue rectangles are bigger than the curve. If I made one that stayed below, using that same sort of delineation, I would skip the first one, but then use everyone afterwards. While the blue one, it was the very first point at 0. So this would be our lower estimate. We would take a look at what our width is. So I'm going to start with upper this time. So how far apart are all of those? So let's go 0, 2, 4, 6, 8, 10. So the width in between, the width of all those rectangles, I keep saying triangles, is 2. And then we just need to add up all of these y values. So that's 32 plus 24 plus 12 plus, why did I put parentheses? Plus -4 plus -20, and then we're done. If we don't grab the last one. So we type all that into our calculator. I'm going to cheat off of here, and we get -48. So this thing is approximately -48. If we do an upper estimate, I'm sorry, a lower estimate. Wait a minute. No, wait. This one's 88. My colors are backwards on my key. 88. If we do our lower estimate, we would keep our same width. We would skip the first one because you can see that first one is not on our decreasing curve. And we would grab the second value, which is 24, plus 12, minus 4, minus 20, minus 36. We type all that into our calculator, and oh man, we got a wildly different estimate. Now this one's -48 as our area. So it's somewhere between. So -48 is approximately equal to f of x dx. So it's somewhere between -48 and 88. And that change happens because we're swapping out that -36 with a positive 32. Man, I keep talking negative. So 32 or -36. That's a wildly different value to be using. So we get wildly different estimates for the area underneath that curve.